Super. And then it's like.
Parentheses, 1 plus 0.
All right, let's, okay, my voice doesn't work, sorry. Let's talk about a couple of these. We've got, 15 minutes or something. Okay, I'm sorry. I think I'm good now.
Water.
Yeah, I know. But like I had this whole cup of tea while we've been in here. Okay. Let's look at one of these. Which one?
3.
Oh, well,
2.
there you go. Thank you. We can talk about 3 also, but okay. Ignore this stuff for the moment, right? What does the log base 2 of x look like? It's a log, so something like that. The base is 2, so it's increasing. So that's the log base 2 of x. Now, what does the plus 2 do? Shifts the whole thing to the left. What about the minus 3? Shifts it down. Okay, so it's a log that's been shifted left 2 and down 3. Okay, so this then is going to look something like that. I don't know exactly where stuff is. It might be more like this. I don't know, but it's been shifted left and down. Yes, exactly. What's the domain? Before we shifted, it was the right half. It was 0 to infinity. Then we moved everything to the left. So now it's -2 to infinity. Because that vertical asymptote lives at x equals -2 now. Right? It was the y-axis, then we shifted everything to the left. For a logarithm, the end point of the domain, that's where that vertical asymptote occurs, right? And that's why. What about the range? Yep. It was everything to begin with. You moved it down a little bit. Who cares, right? It's still defined everywhere. The range is still everything. Okay. The intercepts. The intercepts we have to work out a little bit. Right, these things I can kind of get by, just looking at it and thinking about the transformations. The intercepts I need to actually go find. To get an x-intercept, not just here, but always, you let y be 0. So if I let y be 0, that means I'm looking at the log base 2 of x plus 2 minus 3 equals 0 and solving that. What should we do to solve that? Add 3 over. Okay, so add 3 over. And then what? The thing we want to find is stuck inside this logarithm. So I got to get it out, right? I need to make the log go away. How do we do that? How else could we write this? As an exponential. As an exponential. Oh man, you're right. So the log is base 2, so the exponential would be base 2. So 2 raised to the third is x plus 2. This is what I'm talking about. That step at the beginning of class, I said, like, you got to be able to go back and forth between these things. This is why. The way you get rid of the log is to rewrite it as an exponential. Now, I got to figure out what 2 cubed is, but that's not that big a deal. The other side, though, now it's just x plus 2. It's not the log of x plus 2. It's just the inside part. That's 8. So x is 6. That's not. Here we go. So the x-intercept is the 0.60. Okay. How do you find a y-intercept? Set x to 0. So to get the y-intercept, I'm going to plug in 0. It's the log base 2 of 0 plus 2 minus 3. So it's the log base 2 of 2 minus 3. What's this? How many 2's are in 2? Just 1. Again, calculator will do that for you, right? You don't have to. But 1 minus 3 then, this would be -2, 0. Oh, hey, so my drawing's not that bad. Oh, sorry. I wrote those coordinates backwards. 0 minus 2. 0 minus 2 there. 6, 0 here for the x-intercept. Okay. I don't think there's anything in like the homework where like you get into quite that much detail, but this is good that we're, this is tying a lot of the things together, right? The domain. Here we were able to do it by transformations. Elsewhere, we might need to work some stuff out a little bit more. The x and y intercepts, we're setting up, we're solving, we're evaluating. This is tying a lot of these skills together. Finding the domain for something. Again, the without a calculator part, what I really mean is, you're going to have to work out some details, right? I don't mean that you can't look at a graph or whatever, but for finding the domain for something like this, what does that +1 do? Shifts it up. So does it matter at all for finding the domain? No. So ignore this. What do we really need to be looking at? The stuff inside the parentheses, inside the log. And what we need to know about it is where it's positive. Now, if you can look at that and figure out what all the transformations are, like good for you, that's fine. There's a shift, there's a stretch, there's a reflection. Again, they're all happening at the same time. To be sure then about what's going on, I'm just going to take this aside and solve. I'm going to figure out where it's equal to 0, which is at 4/3. That's where the vertical asymptote is. So that's how far the thing has shifted, right? It's actually 4/3 shifted to the right. But then to make sure that I'm sort of capturing, the right side of it, I could look at a graph. I could, if I can pick out the reflection from here, that works. I could just test a couple of points. If I take something smaller than 4/3, then what I have is the log of 4. And the question is basically like, is that a real number or not? Is that defined, right? Can you take the log of 4? Yes. I don't know what it is. I also don't care what it is. Just that it exists. On the other hand, if I take something bigger than 4/3, like 4, I'd be looking at the log of 4 minus 12, so -8. That is not defined. That is not a real number. I can't take the log of a negative. So the domain is -∞ to 4/3. It's everything to the right, whatever direction that is from 4/3. Okay. All right. The interest problem, everybody's good there. Semi-annually in is 2, weekly in is 52. Continuously use the other formula.
I think the answer is like,
They're all like 17,000 something.
yeah, I think.
Yeah.
Like first one was 17,580.
Right. Yeah. Yeah. They're all kind of in the neighborhood of 17.6. Yep.
Yeah.
Good. Okay. This one. Here's a graph. You need to identify domain, range, asymptote, and then figure out where it came from. Everybody okay with finding the domain and range and the asymptote from the picture, right? We don't really even need to know what kind of thing it is to do that. Just look at it and what it tells us, right? So what's the domain? And the range? Yeah, watch out, that asymptote's at -1, so the horizontal asymptote is y equals -1. Okay. Now to figure out where this graph came from, right? Now we're trying to figure out whose graph we're actually looking at here. Now we need to think about things a little more deeply. Is this an exponential or a log? How do you know? Okay. What else tells me it's exponential? There's a horizontal asymptote. And that's how exponentials work. I don't really mean to write out the whole word asymptote, but okay, so it's exponential. It's growing over time, right? That means the base is bigger than 1. Okay. Now, exponentials typically die off or approach asymptotically the x-axis. This one, it's at -1. What does that mean? What would be the most straightforward way we could handle that? Making the asymptote be here instead of here. Yeah. It's shifted down 1. Okay, so ignore that part then. Let's just, think about the curve itself. And then at the very end, I'm just going to tack on a -1 on the outside to handle that part, right? Okay. The thing we really need to figure out and be thinking about here is what the base is. How can we find that? Let's look at some points. From here to here. How far over did we go? And how far up? Okay. 1, 1. Okay, what about from there to the next point? Over 1, but up 2. And then over 1 again, so we're just counting over, right? Okay, I'm gonna stop writing that down because that's boring. How far up did we go? 4. Okay, and then let's look at the next one. Over 1 again, right? But how far up did we go now? From 7 to 15, so 8. So 1, 2, 4, 8. That's the change in y, right? We're counting over by 1s, but the amount we're going up is doubling from one step to the next. What does that mean? The base is 2. It's a base 2 progression, right? It's exponential, so we're multiplying instead of adding, right? It's not, think about doing this with a straight line. You would just do the stair-step slope thing, right? Where you're adding up and over. Exponentials work in a similar way, only instead of addition, it's multiplication. So going 1, 2, 4, 8, the progression there is times 2 from the step before. It's doubling. That means the base is 2. If I had seen it go, 1, 3, 9, something like that, that means the base is 3. So on, right? Can't really get much bigger than that, or it doesn't fit on the page very well. But find the value of the base, that's 2. The function whose graph is shown, it'd be 2 to the x, only shifted down 1. Right, so 2 to the x, then on the outside, right, not in the exponent, but on the outside, -1 to get the shift down by 1. Okay, cool. All right, y'all hang on to those, finish whatever you didn't finish. Let me know if you have questions about things. And I will see you all on Monday.